So welcome back. In a previous lesson, we talked about general techniques that we can use when we want to factorize things. And in this lesson, we're going to focus specifically on factorizing quadratics. Now to start us off, I'd like to talk about factorizing a monic quadratic first. Okay, so to start us out, I'd just like to expand this expression over here. I'm first going to get x squared, and then I'm going to get a times x, b times x, and also a times b. Now after this stage, I'd also like to factorize an x from this step over here. So I'm going to write a plus b all times x. Now as we said before, when you go from this side over here to this side on the left, you've actually expanded the brackets. And if you're going from this side on the left to the side on the right, we call that factorizing. Now anytime you start with some expression and you expand it, you could always take that new expression you have and then factorize it to get back to the original. But as we've also said in the past, expanding is usually pretty easy, but factorizing is generally very hard. Now I think this is better explained with an actual example. So let me bring one up and I'll show you why factorizing is more complicated than expanding. So let's imagine expanding x plus 5 all times x plus 3. The usual way I'd go about doing this is I'd draw a rectangle where one of the sides is x plus 5 long and the other side is x plus 3 long. And then to expand this, I just find all of these missing areas. Now this first one here is x squared, then this is 5x, this is 3x, and 5 times 3 is 15. And then I just add up all of these areas. And now the next step is where all of the trouble occurs. I want you to notice that we're going to add 5x plus 3x to make 8x. So the result would just be x squared plus 8x plus 15. Okay, so as we said, going from this expression over here to this one down here, we call expanding. And if you wanted to go in the opposite order, we'd call that factorizing. Now because factorizing is the opposite of expanding, if we did these two steps to expand, then we want to do these steps in the opposite order to factorize. But then we run into this problem over here. This 8x over here, how are we going to know to break it up into 5x plus 3x? I mean, you could write 8x in a whole bunch of ways. You could write it as 4x plus 4x or 2x plus 6x. So how do we know that we need to use 5x plus 3x? So this is the exact problem we're facing when we try to factorize something. We're trying to find two numbers a and b that add together to give you the number in front of the x. And then when you multiply them, you have to get the number right at the end. Now I want to give you a nice visual way to think about this. When we expanded this over here, we used this picture over here, where we started with these numbers on the outside, and then we tried to find the numbers on the inside. Well, this time we're doing the opposite. We're starting with the numbers on the inside, but we're going to use them to try to find the numbers on the outside. Okay, so the picture I draw goes like this. This x squared over here is the same as the x squared over here. The 15 is the same as the 15. But then, this 8x over here has to be shared between this cell and this cell over here. And the whole trick is to figure out how much of the number to put here and over here. So for example, we could put 2x over here and 6x over here if we like. Or we can put 5x here and then 3x over here. The only condition is that these two have to add to give you 8x. And then if you think about it, the whole goal is to try to figure out the numbers on the outside over here that we started with, as you can see up here. So for starters, we want to just fill out what we know. We know that this number here is an x squared, and the only way you can make an x squared is by multiplying x by x. And now, after this, we know that this number down here is going to be 15. So all we have to do is to find two numbers that we can put here and here that multiply to give us 15. Now in this particular example, I'm actually cheating a little bit because you can already see the answer up here. So if we put 3 over here and 5 over here, everything would work out just fine and you would get 15. And then that immediately tells you that you have 3x over here and 5x over here. And then you just need to realize that 3x plus 5x is the same thing as 8x. Now because you've decided to rewrite 8x as 3x plus 5x, that's exactly what we'd write on the previous line over here. and then I'll show you later how we can work back to this original line. So I'll just repeat this one more time. We want to find two numbers, a and b, that add together to give you the number in front of x, and that multiply by each other to give you the constant term right at the end. Once we know what a and b are, we can immediately factorize to get x plus a times x plus b. Now, I can't really do it with this example because you already know the answer. So how about I give you another example and we work through it together. Okay, so we want to factorize x squared plus 3x minus 28. So to begin with, let me actually draw the same picture I drew before. Okay, so let's start by filling out the information we already know. We know that this side over here is going to have to be x, and this side over here is also going to have to be x. So that just means that the area of this section is x times x, or x squared. Next, we want to find the area of this section, and we know that it's minus 28. If we're going to have a negative area, then one of the sides has to be negative, so I'm going to choose this one to be the negative side. But then we can say a little bit more. We know that we're going to multiply two numbers to give us 28. We just have to figure out what those numbers are. So if you think about it, we can multiply 1 by 28 to get you 28, but we can also do 2 times 14. We can also do 4 times 7, and I think that's just about it. So unfortunately, the best method that we have here is to just do trial and error. We should just try all the possibilities and see which ones work. I'm just going to try, say, 2 and 14. I'm going to choose this side to be 2, and I'm going to choose this side to be 14. And if we do that, we're going to get negative 2 times x here, so this is going to be negative 2x. And then we're going to get 14 times x here, which is 14x. But then I think you can immediately see that 14 minus 2 is not the same thing as 3. It's actually 12. So that means this is not the correct answer. So that one didn't work, but that's okay. Let's just try again. If you try 4 and 7, let's pretend we tried putting the 4 here and the 7 over here. Well, in this case, you just get minus 4 times x, or minus 4x here, and then 7 times x, or 7x over here. And this time, you do indeed get the correct answer. Notice that 7x minus 4x is the same thing as 3x. Now, just in case you accidentally put the positive sign over here, then this is going to turn positive and this will be negative. And then in this case, you just get minus 7x plus 4x, which is actually minus 3x. So you know that you should just move the minus sign over to the other term. But now that we've got the numbers on the outside over here, we've actually finished the problem. I want you to notice that x minus 4 all times x plus 7 is the exact same thing as x squared plus 3x minus 28. Now you could get to this answer directly, but just in case you don't like that, we can show it step by step as well. I want you to realize that 3x is the exact same thing as 7x minus 4x. So I could take this expression up here and replace 3x for 7x minus 4x. Now, once we've done this, we can factor out an x from these two terms, and we can also factor out a minus 4 from these two terms. And now finally, we just need to notice that these two terms both have an x plus 7 in common, so we can factor that out as well, and we just be left with x minus 4 as the remaining terms. So now we just get to our final answer. Notice that x squared plus 3x minus 28 is the same thing as x plus 7, which is this side of the rectangle, all times x minus 4, which is this side of the rectangle. So you don't need to do these steps, but if you'd like to, you always can. Now this is definitely one of those things you're going to want to practice yourself. Do a few examples, and then once you've done that, you should be able to do this on your own pretty comfortably. So now that we've factorized monic quadratics, we should talk about general quadratics as well. A general quadratic is just an expression in the form ax plus b all times cx plus d. Now before we can learn to actually factorize something like this, we should learn how to expand it. In this case, we're going to get a times c all times x squared, and then the constant's going to be b times d. But then, for the terms with x's, we're going to get a times dx, and also b times cx. So as you can no doubt see, adding numbers in front of the x's in both of these expressions leads to a much more complicated expression than you got in this case over here. But we can still do the same thing. We can still factor out this x to write AD plus BC. And we can also say that the order of multiplication doesn't matter, so I'm going to put this x after this. Now in order to solve the Monic quadratic problem, you had to find two numbers, a and b. But this time there are actually four missing numbers, a, b, c, and d. That seems like a lot of numbers to try to find. But it turns out that we can simplify things a little bit for you. The trick is, I'm going to let a and d be the same thing as the letter u, and then I'm going to let b and c be the same thing as the letter v. And now we come to a little bit of a trick here. I want you to try multiplying a times c and b times d. And then after this, I'm going to swap this c and this d over here, because after all, you can multiply things in any order you like. And then we get to the final step of our trick. I want you to notice that a times d is the same thing as u, as we said, and then b times c is the same thing as v. And so if we compare this to what we had over here, we can just say that we're looking for two numbers, u and v this time, that add together to give you the coefficient of x, but then multiply together to give you the product of this coefficient and this constant term over here. Okay, so let's make this clear one more time here. You want to find two numbers u and v this time, that multiply together to give you the product of ac and bd. And then, when you add them together, you want to get the number in front of the x. Now this is definitely something you want to see an example for, so let me bring out an example and we'll work through it together. Okay, so we want to factorize 6x squared minus 5x minus 4. I'm going to start by actually drawing a box to show you exactly what we're doing. So again, we know that this area over here is 6x squared, and this area over here is minus 4. But then the sum of these two areas is the same thing as minus 5x, which is why I've written it in the middle. So let's start by filling out the information we already know. We know that we're going to need an x over here, and we're also going to need an x over here. But I've also put an underscore under these two, because we don't know what numbers we need to multiply to make this 6x. Could be 1 times 6, or it could be 2 times 3, or maybe something else. But then the other thing we know is that this area over here needs to be negative 4. So this term over here is going to be negative. And this one over here has to be positive, because a positive times a negative is a negative number. So that means we're going to finish this problem when we know what four numbers to put in these underscores over here. Alright, well for starters, we know that this 6 over here is the exact same thing as AC. So let's just mark that. And then this 4 is the same thing as B times D. And as we know, if we multiply AC by BD, this is the same thing as A times B times C times D, which we also said was going to be the same thing as UV. So as we said, A times D is going to be the same thing as U, and then B times C is going to be the same thing as V. But we can also write this as AC times BD, and AC is 6, but BD is minus 4. Now 6 times minus 4 is minus 24, so AC times BD is the same thing as minus 24. And then finally we can say that U plus V is the exact same thing as this term over here, which is just minus 5. Okay, so we know that U times V is going to be minus 24, and U plus V has to be minus 5. The other thing we can say is that since U plus V is a negative number, we expect the negative number to be larger than the positive number. So to find U times V, we just need to know the factors of 24. We can write 24 in a bunch of different ways. We can write it as 24 times 1, or 12 times 2, or even 8 times 3. And now we just have to try adding these factors to see which one of them actually gives us this minus 5 that we're after. So 1 minus 24 is going to be minus 23, so that's not the right answer. And 2 minus 12, well, that's minus 10, so that's not the right answer either. But 3 minus 8, now that's minus 5. So that is actually what we're after. So this is basically telling us that we should rewrite this minus 5 here as u plus v, or 3 minus 8, all times x. Now that we've done this, we just have to reverse the final two steps. Notice that over here we can factor out a 3x, and then over here we can factor out a minus 4. Now, just like we did before, we can see that we can factor out a 2x plus 1, because that's a common factor here. So we'll just be left with 3x minus 4 as the other factor. So therefore, we've come to the final answer. We can see that factorizing 6x squared minus 5x minus 4 results in the expression 2x plus 1 all times 3x minus 4. And this tells us how to fill in our underscores now. You can see that since this is 2x, we can just put a 2 here. And then this one over here is just this 1. Now this underscore is going to be a 3 because we've got 3x, and then this negative underscore is going to be the 4. Okay, so this just tells us that if we wanted to find this area here, the width is 3x and the height is 1, so the area is just going to be 3 times x. And then, to find this area over here, we can see that the width is minus 4 and the height is 2x, so the whole area is just minus 8 times x. And now if we look carefully, we notice that everything's just come full circle. If we look at this 3x over here, we can see that the number 3 is the same thing as our u. And then this minus 8x over here, well, the number here, that's just the same thing as our v. So if you then look at this final result we got here, if you just look at doing the steps backwards, wouldn't expanding it lead you to this step over here? And then if you just added the 3 and the minus 8, you'd end up with this expression that we started with. So then in a sense, you can sort of say that this technique of finding u and v is sort of like undoing an expansion. But just like the last example, watching me do it is not really going to help you learn how to do it yourself. So you really should get some examples out and try actually figuring out how to factorize them yourself. You can even make examples by just multiplying two random brackets, like I've shown here. And in fact, that is exactly how I came up with this question myself. So now I'd just like to summarize this lesson. At the beginning of this lesson, we talked about factorizing monic quadratics. We found that if you took a quadratic like this and expanded it, you'd end up with x squared plus a plus bx, all plus a times b. And then we said you wanted to find two values a and b such that they add up to give you the number in front of the x, and that they multiply together to give you the number right at the end. But then after this, we talked about generalizing it to a general quadratic, in this form ax plus b all times cx plus d. When we first expanded this, it looked like there were 4 numbers for us to try to find. But instead we came up with a very clever trick. We decided to let AD be the same thing as u, and BC is going to be the same thing as v. After this, we noticed that if you multiply AC and BD together, you just end up with the same thing as u times v. So that means we just want to find two numbers, u and v, that multiply together to give you this number AC times BD, which is the product of this and this, and we want them to add together to give you the number in front of the x. Now, just in the interest of being really honest with you, later on, not so far from now, you're going to learn about a technique known as the quadratic formula. And when you learn about the quadratic formula properly, it can help you find the answer to these sorts of questions really, really quickly. Despite the fact that the quadratic formula will always work, it is actually really handy to be good at factorizing things like this really, really quickly. So you should do a bit of practice and get good at doing both of these things. Now believe me, having to pull out a really long formula every single time you want to factorize something like this or this is going to be really, really annoying. So you should just practice them and get good. Now that just about completes everything I wanted to say about quadratic factorization. Now just as a side note, you can combine quadratic factorization with all the other techniques of factorization that we covered in an earlier lesson. So you'll want to look for those problems and solve them yourself. But now I think I'll end the lesson there. So I'll see you next time, where we'll talk about other techniques that you can use in your study of algebra. Thanks for watching another Trina video. If you want to say thanks, you got to show your friends. Or maybe you should just visit us at trina.org, where you can track your progress and have access to questions and heaps of other awesome stuff. Or maybe you should just like and subscribe. That works too. But either way, I'll see you next time.